All right, here's my next project. This is a Winnebago Solis Pocket, and the Pocket sort of denotes the size of this Class B van. It's a short wheelbase. Is it a short wheelbase? 150 standard 159 ProMaster high top. Beautiful color. The customer just had it detailed, and this is in for a power system upgrade. I like this little van. This is really cool. It reminds me a lot of the Overland Van Project, the OVP vans that I used to help build back when I worked in Portland. It has the Murphy bed over some tall utility boxes over the wheel wells. They're countertop height. Your whole bed just kind of folds up over there and then it's out of the way. And it gives you this pass-through design, which I absolutely love, these pass-through design vans. The utility boxes have tons of little cubbies that are accessible from the inside and from the back. This is the propane tank in there. There's like this little molly board that's a door, magnetizes open and close. So you can pack this garage area with stuff. You don't have to worry about spilling forward. You could put your dog or something back here maybe. And they kept it simple for this little pocket, right? There's no hot water heater. There's just cold water stuff. Have a secondary water pump switch back here, which is cool. Some valves, a little cold water sprayer, other ports here. It's very utilitarian. I did notice up here that they have, a very simple, there's this water level sensor. It's just a sight gauge, I guess. And I think it's actually a tube in there that fills with water. It's a little dirty, actually. So when you light that up, you'd be able to see your water level, which may or may not work in the long term. Gravity water fill here. I love having this like workbench. Not to mention, you can still put a full piece of plywood in here, like standing on edge. It's really nice. And then having a dinette like this is perfect for two people. Dinette here to sit, talk, play games. I think there's a swivel on the passenger seat. And then the galley, right? We have a cooktop that has a cover, so you can use it as counter space. And then just like the OVP vans, the fridge is on the front of the galley, which is really cool. You can maybe grab stuff from the door if you want to. Electrical system very lacking, as is the case with many of these production line campers. So we have our solar charge controller. You can see the battery is very low. There's our battery monitor. It's just that. It's just 4 lights. Obviously very low. A propane Truma heater. And so, yeah, with this system, with this install, the challenge is definitely space. The batteries are located under the vehicle. They're undermount AGM batteries, which we're going to be replacing with these Li-Time lithiums. Now, with like a lower quality component like this and like this Dakota little inverter, I had the client wanted me to buy these and install these. And I don't want to warranty them because I don't use them a lot and I don't know, I just don't know. So they bought them. I'll install them. These will go underneath the van. We'll use some MRBF fuses on each battery to keep them protected if there is any, accidents under there. 2000 watt inverter, very tiny, very tiny. I did load test this inside with, a bunch of appliances, and it seemed to do okay in, the 10 minutes that I ran stuff. But right, the space of like, where are we going to put all of this stuff? Because in this bench, we have the ProMaster spare tire tools and jack that usually is under the front passenger seat. And why did they take that out? Oh, I guess they just use that as storage. I guess there's a swivel on there too. I don't know if they modified the seat bases. Maybe they did. There's also some ducting in here for the propane system, so there's not a whole lot of room right there. This bench up here is open, but the client had said, like, I'd really like to keep that for storage because, with all the little cubbies and stuff around here, yeah, that's great, but I guess there isn't a whole lot of storage for long-term travel. So we're going to be I'm going to try to work with this space right here. And then we also have some space back here. This is the stock power center. It holds our, it's like a Wifco box, our 120 breakers and our 12 volt fuses. And, there's some room in there for something that we don't need to access, cabling and whatnot. The inverter is going to go here. There's a shoe rack that goes here. So this is not available. There's some space up in here that we could use. This is all hollow, like behind this panel, which It is a little unfortunate. I'm not sure how I can take advantage of that. But yeah, the first challenge is figuring out where we're going to put all this stuff. So this is the inverter that we're going to use. We're going to throw in a DCDC charger. This is our solar charge controller. We're going to take the 170 watt panel that's up there now, the ZAMP panel, and put up 300 watts in two Rich Solar 150s. We're going to add a legit battery monitor, a Victron BMV. We're going to update the original battery, like, what do they call this? Power converter, to a lithium capable model, because there's no inverter charger, right? So there's got to be some way to charge the batteries from shore power, and that's going to be our charger. Now, typically in my installs, I'm using this modified Lynx power in, and this is something that works well with this switch. I just mount this to the positive end there. Our BMV mounts to the negative, and then all of our chargers and all of our loads, you know, come out here or off the end. But this thing is really big, right? And it's, I don't know, we don't have a whole lot going on. We have 2 chargers. We have this inverter. It's a pretty simple system. And because of that, it made me consider using this. And this is my first time using one of these. This is a MRBF, like fuse block. And so it's rated for 300 amps. It gives you space for 3 MRBF fuses and then a place for your main power lead. So I'm thinking that I'm going to do, you know, batteries with their fuse on there. Each cable, they'll run in parallel. And then our 2-aught cable, which is what I use for 2,000 watt inverters, is going to run up under the van to this thing. And then we're going to have our inverter, our DC-DC charger, and our solar charge controller there. We can run whatever power we need for the stock DC system off of this. We could add a breaker switch if we wanted to, or if there's not a fuse, we could add a different fuse off of that. We could use one of these terminal fuses on here if we wanted to add a separate MRBF fuse. Yeah, so that'll be like our positive bus bar and fuse center, and then this, we'll use like a negative bus bar. Instead of this big 400 amp switch, I'm going to use one of these smaller M series battery switches. This is rated for, what's this rated for? Continuous 300 amps, right? So it matches our bus bar here. And because of all these things being somewhat separate like that, we can keep this separate. We can put these things in different places, so it's not as big as one massive Lynx power center, which we don't have room for here, and we can separate these things in different places, which is going to work in our favor. So first steps for me are going to be get underneath the van, replace the batteries, and understand how we're going to tap into what Winnebago calls like I forget what they call it, like a power box or electrical box, and I'll show you that. All right, so here we are under this Solis Pocket. You can see we have our 2 AGM batteries. There's the rear wheels. They're mounted in some undermount trays on their side, and we're gonna leave our batteries here, but replace them with lithium. They have maybe like a 1 gauge cable running off of them. No fuses. And then behind this, and I have the cover off, this is our, let's see, Winnebago calls this the chassis electrical box. And so it has a positive lead from the starter battery. It comes to a solenoid, and this is where like the battery boost switches comes in handy, or this is where the battery boost switch, this is what it activates, sorry. We have a cable that comes over here. This is another like electrically controlled solenoid. That's like the main battery on and off switch, or the toggle that turns the DC loads on and off. Then we have a couple other smaller things. One of these I think is solar. Probably not that one, probably this one. But yeah, we're gonna take stuff apart from here and rewire this. We'll have our breaker for maybe we'll have our breaker up front for our DC charger. But in any case, we're gonna be working with this, the batteries, and then running our power cables probably up through this hole where this styrofoam is located, yeah. And then up into that cabinet that I showed you with the heating duct. All right, so I have my trays out, have our old AGM. When I say old, they're not that old, but they're pretty dead. And so these are the trays that the batteries were in, and then this whole kind of apparatus slides into something that's still underneath. And then once the battery is on its side, then there's this plate that kind of locks it in. But man, look how close it is to the terminals. And when it's flipped around, it's even worse. On the old AGMs, you can see that the studs are kind of midway up. And so that's what this was designed for. So what am I going to do here? I don't even want to put that next to it because that's so close. And you can see that's how that's designed to go through. So what I'm going to do is I'm going to cut this out and cut this out. I mean, I could even leave more if I wanted to. But then I'll drill a single hole through here and then a single hole through the deck. And then I'll have one bolt. I think one bolt's enough. I have tightening points there, and then here to keep that battery in place. All right, so here are my undermount trays. I have some paint. I painted just the rusty metal. I have my new hole drilled. Here's our front, I don't know, brackets cut off, and I painted that. Also put anti-seize on all of the threads because they're just steel and kind of rusty. I also put in some self-adhesive like foam so that when the battery rests in this tray, because you can see where the battery was resting is where it was rusty, so moisture was kind of getting in there. So this is going to create a little bit of a gap between the tray and the battery, and hopefully just make the tray last a lot longer and make it easier for anybody who works on this, which could be myself. All right, so we're back under the van to look at this chassis electrical box, because back up here on this main tray, we have two wires that came off the positive. We have this one, which snakes around all the way back to here and is that red cable. It comes to this side of this solenoid. That's the starter battery. This is the aux battery, the house battery. This is a jumper that goes from this terminal over here, and then this is the DC on-off switch that's up front. And so when the starter battery, when the engine's not running, this thing is open, and so the chassis battery is just going from here to there and supplying the loads. And then that's the fuse, the resettable breaker that goes to the DC loads there. There's a couple other little guys up here. I'm not sure what they do, and maybe I don't need to know what they do. But I do want to figure out what this one is. Oh, it's green. Is it green? It's green. So that was probably a negative. That's simple enough. The other cable over here is the main chassis ground, which is so crazy. I guess they want to go to a stock mounting point, which is way back over there. So they run this cable that far when you could easily just mount it, I mean, anywhere close by. All right, now to figure out where these solar wires go. So we know that they come in through the roof from the panel, and then they go to this charge controller. And then from this charge controller, where do they go? Well, we can see the color of our wire, which is great. Remember that green wire down below? I bet that was the solar, went right to the negative. Looks like we have two inputs, right? One is for the suitcase solar. That's what these folks do. They make it simple. The suitcase solar just goes right from that port, the SAE port, straight to here. So we have two inputs and then one dual output. So if the panels were going together while they were both illuminated, the panels would like average each other in voltage and current, and something would happen where you wouldn't get maybe the full efficiency out of, say, the 170 that's on the roof and the whatever you have on the back, 100 or something like that. And that's okay. And we're going to leave it like that. But we are going to disconnect this thing and then reroute the solar to our new MPPT, which will be located probably in this bench. All right, now I got a light. Well, you can see I have my lithium batteries mounted up on these undermount trays. We have our MRBF fuse kind of just in place, and you can see the the fuse from here, which is great if you need to troubleshoot. Remember, I have that like foam underneath, so now there's a space between the battery and the tray. I did figure out this is the solar, the negative, and so because we don't want any negative connections on the battery before the shunt, this thing is going to get pulled over here and then probably go in through the floor somewhere over there. Now the positive comes out of that same foam area, snakes around. Let's move our light over. Snakes around up top there, and then is that connection there. It goes through one of those crappy resettable or auto resetting breakers, and then it connects to that side of the DC on-off switch, so that it would always be supplying power to the battery even when the DC on-off switch was off. So we're gonna snip that one because those are crimped together. Snip that one off, delete that breaker, and then run that cable back with the negative and bring it up there, and then it'll go to a breaker and then into the MPPT. All right, I'm pretty much wrapped up down here. I have both batteries in. I have our MRBF fuse on each positive terminal. I have 2 aught cables connecting each battery. My cables are running up inside. I had to drill a new hole right next to the one that was here. And I have my battery cables, and then I have 2 6-gauge cables, one for the DC loads and then also the DCDC charger. I have things all wrapped in loom, and then moving up here to this chassis electrical box, right where I have my 6-gauge cables coming around. They'll come in this side, and then they connect to the solenoid here. So this is the DCDC system. And this solenoid controls the battery boost, and then I think it's also ignition activated too. So the way I have it wired up right now, the client loses the battery boost function, which, is something that people really think they want. But when it comes to jumping a lead acid, a very dead lead acid from a very full lithium, you can kind of get into trouble. And so I just kind of take that out. And then over here is our DC load center. So our 6-gauge comes to that side. This is the little doohickey that's controlled inside at the panel, and then that's the output. Still got to tighten that up, put the cover back on here, and then we're all baked. Besides our main ground, which is probably going to come out somewhere down here and attach to the frame, because the one that's currently there is just a little inadequate. All right, here we got our panel. This is the original 170 watt Zamp solar panel. We're going to pop this off and install 2 150s by Rich Solar. Now this has got this like rubberized sealant over it. It might even be like a lap sealant. I have this like painter's knife that I've sharpened the edge so it's very sharp. We're going to just get all that off and then pull out whatever fasteners are there and clean up our surface. So you can see the original panel is removed, and I just have the packing from the new panels. I unpacked them, and this is the exact size of the panel. And I'm using this to just come up here and kind of lay out where the panels go, how they fit, and where I need to put my mounting feet. And in this case, I'm just going to use Z brackets 1 and 2, 1 and 2, and they'll fit right on this rail here. Over there, you can see we have that other, I don't know, roof entry port that's kind of blocking where the feet might go. So I just made a mark of, where the feet can't go, and then I can bring these down, and this is the front, this is the rear one, this is the front one, passenger. So I know where to put my Z brackets. So I'll just mount them in the shop and then bring them up here and install them. So up here under the driver's seat is the starter battery, and this is where Winnebago brings their DCDC line. from this side of the fuse. So this line comes from the alternator, goes through a main fuse, and then it goes into a small distribution panel here. And so Winnebago attaches it to this side. I don't like to get on this side. I don't want to draw more than is supposed to flow through here. So I always connect mine to like the other side, the unfused part of the battery. And so I'm going to be adding in this 60 amp surface mount breaker for that DCDC line, because there's no breaker here for this. I guess they're relying on that mega fuse from the factory to protect that line, which I don't really know if that makes sense. I can't really see what the current rating is on that. So I'm gonna pull this off, connect it to here, and then connect it back to the battery. All right, so here's the basic idea. I was able to kind of loop that original cable around and then attach it to a surface mount breaker and then screw that into the plastic over there. So it's a little loose, but once the battery cover is on, it'll hold it down. Then we have a 6 gauge coming off the breaker all the way over to this stud here that comes right off the battery. I had to cut some of this plastic off the side. It looks like hell because it's cold and the plastic kind of cracked. But that makes the cover fit nice. And then we'll just put the cover back on and then we're good to go. All right, pretty much wrapped up in here. I still have to put our stock ProMaster spare tire tool kit on here, but you know, it rests on these two pieces of wood. So I kind of had to design all this stuff knowing that I would slide something in here and drop it down. So this is still loose and that's just going to rest on the metal plate. But we have our DCDC charger, our solar charge controller over here. We have our cabling. This is our solar breaker. Then over here is that MRBF fuse block with our 3 fuses on there. And then down here where the original ground bar was, I put the shunt and have some, you know, all of our cables coming through the floor of the van right there. And then all that stuff snakes, I put another hole there to get it to the other side. And this is all behind this WIFCO box, which was pretty tight once I put the inverter in. Let me sneak a little light in here. Now you can see tucked back in there is a 6-post, oh, there we go, a 6-post ground bar, a new ground bar, and that has the grounds for our inverter and our DC-DC charger and our solar charge controller. And I moved all of the original stock DC circuit grounds, or I guess they're the negatives from all the circuits over there. And then we have our 2 cables going up to our inverter, which pop out of a hole right there. I'll probably zip tie these together, and then they're connected to our small, it works, our small 2000 watt Dakota inverter. Now I'm going to push all this stuff back in, put the plate on there. I have the new lithium converter installed. That's a 55 amp WIFCO lithium auto detect converter. Turn all these things on. So even though this rig has this inverter now, the only inverter powered outlets are right on the inverter itself. We have our main on and off switch right there for our battery power. Up here at the solar junction, this is where the original ZAMP charge controller was. Remember, we took that out, and then I installed 2 tiny power posts. These are Blue Sea 1/4 inch, or I think maybe even number 10 post, and just screwed them, self-tapping screws, making sure that on the other side of that wasn't the door slide, but there is some room there, so they're attached. And then I'll just make a false black panel to cover that up. And then we're pretty much wrapped in here. What else did I install? The readout for the BMV. So I was able to snake our cable for the BMV up the pillar, inside of the pillar, and it goes straight up here. And if you pop this cover off and make a slit in the reflectix, you can run a wire fish down, and then that's what I did. I pulled it up, kind of snake it around this panel there, but looks pretty good. Looks stock. Pretty pleased with how this turned out. I'm going to take another video just to see maybe how that fits in so y'all can understand a little bit better about that. Here's the final product. Nice and tidy. I did have to move this kind of over and up a little bit to get the whole unit to slip in. But yeah, let's run it through some tests and then we'll give the client a call for pickup.